All right, so today we are still finding critical points just like we were doing last week. We're still working with quadratic equations. But today, the big difference is we are going to be working in standard form rather than vertex form. So our problems will start in a different form, but we're still going to have the same types of answers that we were looking at last week. So standard form, the way that standard form is written out is we have f of x equals a x squared plus bx plus c. So notice this looks fairly different than what we were looking at last week. So a lot of the process of coming up with our critical points will be different, but some of it will end up being the same. The biggest difference is the things that we have to calculate will be different. When we were in vertex form, we were able to come up with the vertex without any calculations at all. In standard form, we will have to calculate our vertex. But the trade-off is we won't have to calculate our y-intercept. And we'll talk more about that in a moment. But we are still going to be finding the same things. We're still going to be finding the vertex. We will still find the axis of symmetry. And we'll still be finding the y-intercept. We will also be determining if the vertex is a minimum or a maximum. So you're still finding the same 4 features of our graph that we were looking at last week. We're just starting with different information this time. We're starting in a different form. So when we want to calculate these, the vertex in this form is the one that actually needs the most work in order to calculate. So for the vertex here, we actually have a formula. And that formula is going to be the x value for the vertex is equal to negative b divided by 2 times by a. And I could explain where this formula comes from, but it'd probably take me about 15 minutes to do so. And I don't necessarily think that you all are interested in that explanation. Yes. Yes, yes. And the A, B, and C that we're looking at are the A, B, and C that we see here in our formula. We'll look at an example in just a little bit, but this B that we see in front of X is going to be the B that we have in this formula here. The A that we have on bottom of the formula is going to be the A that's in front of X squared. So that will give us the X value of our vertex. To find the Y value of our vertex, find y, you're going to plug the x value into the equation that you start with. So this is going to be where the majority of our work is on these problems, is calculating the vertex here, because we've got a formula that we have to use for x, but then whatever number we calculate for x, let's say that x is equal to 5, you would take that number and you would plug it in for both of your x's in your original equation, and you would work out what the result is. The result there would give you the y value for the vertex. The next thing we need to find is the axis of symmetry. And just like before, the axis of symmetry is going to be calculated the exact same way. So this is one of the things that does not change. So in this case, the axis of symmetry is still going to be x equals the x value the what? Oh, down here, yeah, just cut off. It's y-intercept. We'll talk about that in a second. Up here? Yeah, so this is not the y-intercept, but the y value of the vertex, because it's a point with both x and y. The x value we get from the formula, the y value we get from plugging whatever number we get here. We're going to plug that back into the original equation and work out what the result is. The y value is actually much simpler. But the axis of symmetry here is going to be x equals the x value of the vertex. So the axis of symmetry is found and calculated, well, not calculated. The axis of symmetry is found the same way that we did when we were working in vertex form. It's just the x value of the vertex. No calculation necessary for the axis of symmetry. The y-intercept just as before, we could plug 0 in for x. And simplify. But what we're actually going to find with this particular form is that if we put 0 in for this first x, then this whole first part goes to 0. If we put 0 in for this second x, this whole second part goes to 0, which means the only thing we're going to be left with is whatever we have for c. And so in this case, for standard form, our y-intercept is always going to be the point 0, comma, c. And we'll see an example of that here in just a minute. But there's not really any calculations that we have to do for the most part for our y-intercept. The last thing that we need to determine is we need to determine whether the vertex is a minimum or a maximum. This is done exactly the same as we did when we were in standard form. Does anybody remember what letter did we use to determine whether our graph opened up or down? A. We also see an A right here in our equation. That A that we had previously is the same as this A right here. So they are treated exactly the same. So if A is greater than 0 or positive, then the graph opens up and the vertex is a minimum. If A is less than 0, then the graph opens down and the vertex is a maximum. Exactly the same as we had seen last week in vertex form. So the way that we determine whether we have a minimum or a maximum is identical to what we were doing last week. Everything about that process is the same. The a is in a slightly different position, but this a in front of the x squared is the same a as we had in front of our parentheses for vertex form. All right, so just as we saw last week, we're going to have the same types of instructions. Find the vertex, axis of symmetry, and y-intercept. Determine if the vertex is a minimum or maximum. And then we are going to have this equation right here. Let's have f of x equals 3x squared plus 12x plus 17. With what we were seeing last week, before we did any calculations, we had to find A, H, and K, because those were the three letters that we had when we were dealing with vertex form. This time, in standard form, we don't have A, H, and K, we have A, B, and C. So we want to find these three things before we do any of our calculations. And these three numbers always come from the number in front of x squared, the number in front of x, and the number that is added or subtracted on the end that does not have an x with it at all. So in this case, A is going to be equal to 3, B is going to be equal to 12, and C is going to be equal to 17. For the most part, I will always give this to you in this form here, but for some reason there's multiple x's. Let's say you had 3x squared plus 5x plus 7x plus 17. You would want to combine any of those like terms together before you determine your A, B, and C. There should only be one x squared term, there should only be one x term, and there should only be one constant term, which is the term without any x's here. So like I said, if you have more than one of those, you want to make sure that you combine those together, combine your like terms before you determine your A, B, and C. So now I'm going to start by finding the vertex. The formula that we had for the vertex was x equals negative b over 2 times by a. And I would encourage you to write this formula down again, because every problem that we're going to see here today requires this formula right here. So if you only have it written one place in your notes, write it down again, because it's one that you cannot forget, because you have to use this in order to work these problems. But now I'm going to plug in my b in my numerator, and I'm going to plug my a in my denominator here. So the negative sign stays from the formula. The 2 in the denominator also stays from the formula, but now I'm going to be plugging in 12 in the numerator and 3 in the denominator. So I now have negative 12 over 2 times by 3. And so this will give me negative 12 over 6. And then we can do negative 12 divided by 6 to get x equals negative 2. So we've got our x value here. We don't have our whole vertex, we just have the x value. We still have to find the y value. But I want to pause here and see if there are any questions or things that are not making sense. All right. For the most part, the problems that I'm going to give you will always have an x value that comes out to be a whole number. If you get something that's not a whole number, let me know and we can check your work together. It's possible I made a mistake, or it's possible that you made a mistake. We'll see what happens. But for the most part, I'm only going to give you problems that have x as a whole number, because whenever we have fractions or decimals here, that makes these problems fairly complicated. So now we need to find the y value. And we said that the y value, we need to take this x value and we need to plug it in for our x's up here. So that means y is going to use this whole original formula right here. So 3x squared plus 12x plus 17. And I'm going to replace both of these x's with -2. And you have to make sure that you plug in for all of the x's, not just one, not just the other. You have to replace both of them here. But the 3 is going to stay the same. Now I'm going to have parentheses with the squared outside. I'm still going to have the 12. Once again, I'm going to use some parentheses. And we still have this 17 right here. But now inside those parentheses, I'm going to plug the -2 that I just calculated. Oops. So if I continue calculating this, bring this up here. -2 squared, what's that going to give me? +4, because we have -2 times by itself, -2 times by -2 will give us a +4. Well, actually, rather than writing that, we still have the 3 out front. 12 times by -2 is going to give me -24. And then we still have the +17. And we keep going with it. 3 times by 4 is going to give us 12. We still have -24. We still have +17. And so when we combine this together, make sure you are working left to right. PEMDAS does list addition before subtraction, but addition and subtraction happen at the same time, meaning that if we have both addition and subtraction right here, I have to work left to right. So I want to do 12 minus 24, not 24 plus 17. Got to work left to right. So 12 minus 24 gives us -12. -12 plus 17 will be a +5 right here. So that means with these two numbers, my vertex is going to be the point -2, +5, because that's the x value that we calculated first and the y value that we calculated second. So our y-intercept is going to be the point 0, 17, or in general, you can shorten this because we don't necessarily have to do these calculations every time, because every single time it's going to come out to be 0, c. So whatever number you have for c will be the y value for the y-intercept, and 0 will be the x value for your y-intercept right here. So we have all 4 of the things. Oh, actually, we still have one more. We still have one more thing. We have got 3 of the 4 things. We've got the vertex. We've got the axis of symmetry. and we have the y-intercept. The last thing we need to determine is we need to determine whether the vertex is a minimum or a maximum here. This one is worked exactly the same like we saw when we were dealing with vertex form. We want to look at A. So in this case, A is +3. So if A is +3, is our graph opening up or is our graph opening down? It's opening up, which means our vertex will be what? A minimum or a maximum? Minimum. Perfect. So we're going to write that out and we're going to explain that. I am really, really out of space here. Since A equals 3, the graph opens up and the vertex is a minimum. So that last one is identical to the way that we work out things with vertex form. So this time, let's look at a new equation here. Let's have f of x equals 2x squared minus 4x plus 7. Actually, not plus 7, plus 1. So just like the last example, I want to start by finding A, B, and C. In this case, A is equal to +2. B is equal to -4. And C is equal to +1. So just like the last one, we are also starting off with our formula x equals -b divided by 2 times A. If you came in a little late or you don't have this formula written down, this is the most important formula that we need for these problems here. I would encourage you to write this down repeatedly, because if you don't have this formula, when we take a quiz or a test, it's going to make these problems nearly impossible. We have to have this formula in order to get things to work out the way they're supposed to. So we need to plug our numbers in here. I know that I have a negative in the numerator from my equation. I also know that I have a 2 in the denominator from my equation. But when I plug in my numbers, I know that I'm also plugging in -4 in the numerator. So that number that I'm plugging in is also negative. So I've got 2 negative signs in the numerator, which means I'm going to put some parentheses around these to make it a little bit more mathematically accurate. Doesn't change how I do the problem, it just makes it look a little nicer. So then in the denominator, I have 2 times by A. Well, A is also 2, which means I've got 2 times by 2 in the denominator here. If I start to simplify this, in the denominator, 2 times by 2 is going to be 4. And if I have this double negative in the numerator, what's going to happen there? It's going to turn positive. So I just have a +4 in the numerator. Meaning that I've got +4 divided by +4. And what should that give me when I divide those? X equals what? 1. So now we're ready to take this X value and we want to plug in for both of our X's here so that we can find our Y value. Because we're going to have Y equals our whole equation. But now we're going to substitute these X's for the X value that we just found. So I'm going to put ones, positive ones in both of these parentheses here. So if we start working this out, 1 squared, what's 1 squared? 1. Because remember, 1 squared is 1 times by itself. 1 times by 1 is still 1. We'll have the 2 out, oops. We'll have the 2 out front. Four times by 1 is 4. And then we still have the plus 1 on the end. So as we start to simplify this, 2 times by 1 will give us 2. Then minus 4 and plus 1. Which means that if we calculate this out, 2 minus 4 is -2. -2 plus 1 is going to be -1. So what would be our vertex here with this X value and this Y value? Perfect. +1, -1. I don't think I had any issues with this, but always please remember to make sure you label what your points are. I'm asking you for several different things, and it's always important to make sure you say what is what. So obviously, if you have your vertex here, just say that it's the vertex so that I know that it's not the y-intercept or anything else that we're dealing with. So then next up, we need our axis of symmetry. What is our axis of symmetry for this problem? So, perfect, x equals 1. So remember, when we have the axis of symmetry, we need to make sure we write it as an equation. So it's not just 1, it's x equals 1 in this case, but we just get that number from the x value of our vertex right here. So that +1 that we got earlier at the very beginning, that one is the one that we have for our axis of symmetry. That number is going to be the same 100% of the time. So next up, we need to find our y-intercept. And for the most part, I am not going to actually plug in the zeros here for these because it's a bit unnecessary. The y-intercept is always going to be 0, c. And then in this case, we see that c is equal to +1, which means my y-intercept is going to be the point 0, 1. like so. Everything making sense so far? Anything that needs clarification? All right, then the last thing we need to do is we need to determine whether our graph opens up or down to find out if we have a minimum or a maximum. So is our A is +2. Does our graph open up or does our graph open down? It opens up. So since A is +2, then the graph opens up. And if the graph opens up, is our vertex a minimum or is it a maximum? It's a minimum. So those are the 4 things we need. And just as a reminder, here's a visual illustration for the last part here. So if the graph opens up like this, then the vertex is down at the bottom, and we call that a minimum. If, on the other hand, the graph opens down, so A is negative, then the vertex is at the top, and we call that a maximum right there. Questions on this? Things that aren't making sense? Y'all feel like you're ready to try one of these out on your own? All right. So let's have this one right here. F of x equals -4 x squared plus 8x plus 2. So same thing as before. I want you to find the same things. Find your vertex, your axis of symmetry, the y-intercept, determine whether the vertex is a minimum or a maximum. All right, let's talk through this real quick. So first up, we need to identify A, B, and C. So in this case, A is -4. B is going to be 8. And then C is going to be equal to 2. So we're using our same formula as before. X equals -b divided by 2 times by A. So when we plug in, we know that we have our negative from the formula. We also know that we have the 2 on bottom from the formula. In the numerator, I'm going to be plugging in 8, since that's our B value. And in the denominator, I'm going to plug in -4, since that's our A value. So I have 2 times by -4 on bottom. Which means when we calculate this out, we're going to have -8 on the bottom of our fraction, and we're going to have +8 on the top of our fraction. Or sorry, and -8 on top of our fraction. So -8 over -8. And that will give me x equals +1. Now, once we plug in, we need to replace both x's with +1. And then we can start working things out. 1 squared is 1. So we have -4 times by 1. 8 times by 1 is 8. Plus 2. So -4 times by 1 is -4. Plus 8 plus 2. So when we combine these together, we get y equals 6. And that means we have a vertex of +1, +6. That also means we have an axis of symmetry of x equals +1. If we find our y-intercept, remember, is 0, c. So in this case, our y-intercept is going to be 0, +2, since that's our c value. And lastly, we need to determine whether we have a minimum or a maximum. Well, in this case, a is equal to -4. That means the graph opens down and the vertex is a maximum.